On some problems that relates to hypothesis testing of the population mean. So let's start with this one. Number 1, a factory has a machine that dispenses 80 milliliters of fluid in a bottle. An employee believes the average amount of fluid is not 80 milliliters. Using 40 samples, he measures the average amount dispensed by the machine to be 78 milliliters with a standard deviation of 2.5. Part A. State the null and alternative hypotheses. Now feel free to pause the video if you want to try this problem yourself. So let's go ahead and begin. So let's start with the null hypothesis. So this is going to be the status quo. This is the machine in the factory. It dispenses an average of 80 milliliters. Now the alternative hypothesis, this is what is being tested. The employee, he believes that the average amount of fluid is not 80, and so he's conducting a test to show that's the case. So we could say that mu does not equal 80 for the alternative hypothesis. Now part B, at a 95% confidence level, is there enough evidence to support the idea that the machine is not working properly? What would you say? Well, first we need to determine what type of test we're going to do. Is this a one-tail test or a two-tail test? The fact that the alternative hypothesis does not equal 80, that means it could be more than 80 or less than 80. It could be on the left side or on the right side. We need to conduct a two-tail test. So let's draw a normal distribution, and we're going to shade the area to the left and the area to the right. Now the confidence level is 95%, so that's 0.95, which means the area of the shaded region is 0.025 on both sides. Now the z-value that corresponds to a 95% confidence level is 1.96. So these are the critical values. They separate the rejection region from the failed to reject region. The shaded area is the rejection region. Now, in order to determine if we should accept or reject the null hypothesis, we need to calculate the z-value and compare it to the critical z-value, which is 1.96, positive or negative. Now let's write down what we know. So we know that the sample mean is 78. The sample standard deviation is 2.5, and the sample size is 40. Now, if the sample size was less than 30, we may have to use the student's t-distribution. But the fact that it's greater than 30, we could use the normal distribution and get the z-score, since n is large enough. So we're going to use this formula. It's going to be x bar minus the hypothesized mean over the sample standard deviation divided by the square root of n. So x bar is 78. The hypothesized mean is 80. The sample standard deviation is 2.5 over the square root of 40. 78 minus 80, that's going to be negative 2. And 2.5 divided by the square root of 40, as a decimal, it's about 0.39528. So negative 2 divided by that number gives us a calculated z-value of approximately negative 5.06. Now, if we place that on the number line, on the graph, it's in the far left. So notice that it's in the shaded area, the rejection region. So this tells us that we should reject the null hypothesis. So we could say that with a 95% level of confidence, we cannot accept the null hypothesis that the average amount of fluid dispensed by the machine is 80 milliliters. So with 95% confidence, we believe that the machine is not working properly. And that's all we could do for this problem. That's it. Now, before we move on to the next problem, there's something I do want to mention. Because I simply stated that for a 95% confidence level, the z-value is 1.96. And due to the symmetry, if you know the right side, you know the left side. But I didn't mention how to get it. I did cover this in another video. So if you go to YouTube